in this video, we are going to be looking at Simpson's 3/8 rule. Now, the Simpson's rule is actually a technique which is used to approximate the integration of functions numerically. There are actually two methods of the Simpson's rule. We have the Simpson's 1/3 rule and we have the Simpson's 3/8 rule. And in this video, we are going to be looking at the Simpson's 3/8 rule. Now, by formula, the Simpson 3/8 rule simply states integral from a to b of the function f of x dx is equal to 3/8 multiplied by h, multiplying this entire function f of x naught plus 3f of x1 plus 3f of x2 plus 2f of x3 plus 3f of x4 plus 3f of x5 plus 2f of x and so on up to the last function f of xn. Now, there's something unique about this formula. The first thing you observe about the formula is that the first function in the bracket and the last function f of xn has not been multiplied by any value. Okay, so the first function and the last function are kept like that without being multiplying by any value. Then if you look at the formula again, you observe that the value of the function when x is 1 and when x is 2 have been multiplied individually by 3. Then moving on to when x is 4 has been multiplied only by 2. Then you start again from what? 3. So these are actually as a result of how many subintervals you choose, right? So in order to explain this clearer, you observe that the first function and the last function are not multiplied by any value, but the next two functions after the first function is multiplied by 3. The third function is multiplied by 2. The next two functions after that 2 is multiplied by 3. The third function is multiplied by 2. The next two functions is multiplied by 3. The third function by 2, and so on up to the total number of subintervals that you choose. Now, what is this h? H just simply means interval. Okay, h equals b minus a all over n, where n itself is actually the subinterval. Okay, n is actually the subinterval. The subinterval is actually a multiple of 3, and that is what determines the length of the equation that you're seeing here. So you can have your subintervals to start from 3, 6, 9 because it's actually a multiple of 3. So depending on the number of subintervals you choose, it also gives you the number of equation or the lengthiness of the equation you're going to obtain. So I always tell students, except otherwise stated, always choose your subinterval as 3 because it makes the equation shorter and makes the question easier to solve and understand. Okay, now let's pick a simple example to explain this concept. Let's say we're asked to carry out the integral from 0 to pi of cos x dx using the Simpson's 3/8 rule. So from this question now, you can deduce simply that a is equal to 0, which is the lower limit, and you can find that b is equal to pi, which is the upper limit. Now, like I said, we now choose a subinterval. So simply take n to be equal to 3 because it makes the equation shorter. If I pick n to be equal to 3, I can now be able to find my interval. Interval h is equal to b minus a. B is pi minus a is 0 divided by n is 3. So this simply implies that my interval h is equal to pi all over 3. Now, having found my interval h, the next thing to do is to split the subintervals between this limit because this subintervals lies between this limit from 0 to pi. So you split them into 3 between these limits. Okay, so let's create a table to split this limit into 3 subintervals. Okay, so we have x, and this is the value of the function at x. So the first is what? The lower limit, which is 0, x naught or a. That's our first 0. So what we do now is simply find x1, which is the next point. So our first x naught is simply what? 0. So from the formula you're seeing f of x naught. So that x naught is the lower limit, right? And that is simply 0. Now we need to find x1. x1 is simply equal to x naught plus the interval h. So this is going to be equal to x naught 0 plus interval there is pi all over 3. That means my x1 is simply pi over 3. So which means my next point there is pi all over 3. Okay. Next, I find x2 x2 is going to be equal to x1 plus the interval h. x1 gave me pi over 3 plus the interval is pi all over 3. So this is going to give me 2 pi over 3. So x2 is actually 2 pi all over 3. So what we are doing is actually to split this interval, this sub-interval between 0 and pi. So it must not exceed pi, and then it must start from 0. So it starts from lower limit, and then it mustn't exceed the upper limit. So since we've not gotten pi, we keep on splitting. Next, we find x3. x3 is now going to be x2 plus h. And this is equal to x2 there is 2 pi all over 3 plus h is pi all over 3. And this is going to give us 3 pi all over 3, which is actually was pi. Okay, so it means we've gotten to the last limit. So the last is simply what? Pi, and you have this. So what we need to do now is to find the value of the function at each of these points. So since we've gotten to the upper limit, which is pi, we now stop. So you see, this now has been split. This interval, this sub-interval, n equal to 3, have been split into what? 3 places, right? So you have it here. The first two, x0 to x1 is the first interval. Then x1 to x2 is the second interval. Then x2 to x3 is the third interval, and you're good, right? Okay, the next thing we need to do now is to find the value of each of the function cos x dx at each of these points. This is x1, this is x0, please. So this is x0, this is x1, this is x2, and this is x3. So we simply find the value of the functions at each of those points. Okay, so next we find, let's find f of x0. That's going to be equal to, remember the function itself is cos x. That's the function. So whenever you see x, plug in the value of x0. x0 now is 0. So we'll have cos 0. And cos 0 is actually equal to 1. You have this. Next, you find f of x1. f of x1. So f of x0 there is actually what? 1. Put it down on the table. Next, you find f of x1. This is going to be equal to cos. The value of x now becomes x1. And x1 there is pi all over 3. So you have cos pi all over 3. So mind you, in front of a trig function, pi appears as 180 degrees. So which means pi over 3 simply means 180 divided by 3. And that is simply 60 degrees. So which means cos pi over 3 is actually cos 60 degrees. And cos 60 degrees, you know the value is 0.5. So which means the value when x is pi over 3 is actually 0.5. Next, you find f of x2. Okay, you find f of x2. This is going to be equal to cos x now becomes x2, and x2 is actually 2 pi over 3. So that's cos 2 pi all over 3. Okay, so which means 2 pi becomes 2 times 180 divided by 3. So 2 times 180 divided by 3 is actually 120. We simply find cos 120. And cos 120 is negative 0.5. So it means we have a negative 0.5. Finally, pi. So we find f of x3. That is when x is pi, right? So that becomes cos pi. And cos pi is actually cos 180. So you find the value of cos 180. And cos 180 simply gives us negative 1. So the last value there is negative 1. All right. So having found this, you can now let's formulate this equation from what we learned earlier. The integral from 0 to pi of cos nx dx using Simpson's 3/8 rule will now become 3 over 8 of h, now multiply. So remember, the first function is kept like that without a multiple. So I have f of x0 plus the next two functions, I will multiply them by 3. So I will have 3f of x1 plus 3f of x2, okay, plus the next function is supposed to be multiplied by 2, but because my function or my variable ends at x3, which means x3 now stands as what? Xn, which is the last function. So for the last function, you don't multiply it by any value. You simply keep it as what? F of x3, because that is our last function. So like I said, the first function and the last function is not multiplied by any value. So you see why it is better to always choose your subinterval to be what? 3. Because with 3, it will shorten the equation and makes it easier for you to solve. Because if you now choose it as 6, it means you're going to be going through this hassle of interchanging between 3 and 2, and you might get it confused and along the line. You never can tell, right? So let's simply plug in the values into the equation. So this integral from 0 to pi of cos x dx is now going to be 3 over 8 multiplied by the interval. Interval gave us pi over 3. So multiplied by pi all over 3. Okay, this times f of x naught, the value of the function when x is x naught is 1. So you have 1 plus 3 times f of x1, and f of x1 gave us 0.5. So 3 times 0.5 plus 3 times f of x2, that gave us negative 0.5 minus 0.5, okay, plus f of x3, and that is actually negative 1. So minus 1, and you have this, okay. So integral from 0 to pi of cos x dx is now going to be, of course, here 3 cancels 3. I have pi all over 8 into, over here I have 1, 3 times 0.5 plus 3 times negative 0.5. So these two actually cancels out. That's 0. So I'm left with what? Negative 1. Okay. So this is actually going to be pi over 8 multiplied by 0, and that integral is actually what? 0. All right, so that integral is actually 0. And if you want to evaluate this from recent, of course, you can still do this by normal integration. So let's prove this by normal integration. So if you're integrating from 0 to pi of cos ns dx, you're simply going to have, if you integrate cos, you have negative sine, okay, negative sine x. The limit is now from 0 to pi, right? So this is actually going to be, plug in the lower limit, negative sine 0, minus plug in the upper limit, negative sine pi. And of course, sine 0 is 0, sine pi is also 0, and then the value is simply going to be 0. So that is the approximate value of that integration using Simpson's 3 all over 8 rule. In the next video, we are going to be looking at Simpson's 3/8 rule for a logarithmic function. And I'm sure you want to be a part of that video, so do well to tap the subscribe button right now and turn on your bell notification so you don't miss out on that video when it drops. I will see you in the next video. Cheers.